Hello, everyone. I'm Valerie. I interned here at BCD over the summer. Thank you so much for letting me take another shot at this presentation of my summer intern project. So again, I'll be talking about the relationship between climate factors like drought and temperature and West Nile virus transmission. I have a background in environmental studies, so I was very interested in climate change and how it intersects with all parts of life, and how it could impact the work of BCD. So, I'll be giving a brief background on climate impacts on West Nile virus, and then I'll go into my process of data collection and analysis and what we found. To start off, I was interested in this project because we are currently in a severe drought despite the current rain, and climate change will continue to increase temperatures and make droughts more frequent and more severe. So my research question was, in Santa Clara County, do hotter and drier years have higher rates of West Nile virus detection than other years? So I read a few papers on the topic, which I won't go super deep into. Um, but what we found is that during warmer years, more mosquitoes survive through the winter, and mosquito activity can begin earlier in the year. And warmer temperatures also speed up the rate of development and reduce the time needed between blood meals for mosquitoes. So each individual mosquito can feed more times during its lifetime. The effects of drought are less studied, but during drought years, there is more stagnant water for the mosquitoes to breed in, and more living things are congregating around fewer water sources, making it easier for vector transmission to happen there. So I wanted to find if there was a relationship between temperatures and drought and West Nile. So this is what I did. Here are some of the variables that I looked at. For climate variables to measure drought, I looked at the Palmer Drought Severity Index. It's a long-term cumulative drought scale. And I also looked at average temperature and average temperature anomaly, which is just the temperature recorded above a baseline over the past 100 years. For West Nile virus variables, I looked at the positivity rate, which is just the percent of pools that tested positive out of total pools in a given time. Adult mosquito treatments, also known as foggings, that we do after a positive detection, and human cases of illness. So first, I got the raw West Nile data from CalServe from 2003 onward, which is as far back as we had data. This is what it looked like over 12,000 pools of testing that we did over time. And then I looked for drought and temperature data specific to the county, which I found through NOAA. And then I turned that drought data into the spreadsheet for drought conditions from month to month and also compiled monthly average temperatures. And then I put all that data into Python Jupyter Notebook to sort and analyze. So I imported and cleaned the data into something more readable here, and I was able to glean things like positivity rates from year to year and month to month. And then I imported the climate data, standardized that formatting, and sorted through the climate factors together with the West Nile positivity data in the same time frame. And through Python, I did a process of random sampling to find whether there was a statistically significant difference between drought and non-drought West Nile positivity. So first, I observed that based on the data that we had, that drought years did have a slightly higher average West Nile virus positivity rate than non-drought years, about 0.75% higher, as we see in this table. But the next step was to find whether that difference was due to chance or if it was statistically significant. So I wrote a function to randomize whether a year was labeled as drought or not. And the idea is that if all the drought and non-drought years were randomly mixed up, there wouldn't be a difference between their average positivity rates. And if there was a difference, that would be due to chance. So again, if drought years did have a statistically higher difference in positivity, there would be a much smaller chance that that would show up in these random trials. So I randomized the labels 5,000 times, taking the difference in positivity for each randomization. And this histogram shows that distribution of the results of those 5,000 trials. And as you can see, there is some variation. Sometimes the randomly labeled drought years had lower rates, and sometimes they had higher rates, but it evened out to 0, basically. But we see that the difference that we observed earlier, that 0.75%, is well within that range of possible random differences. We found a p-value of 0.223, meaning that a more extreme difference than what we observed happened 22.3% of the time in those 5,000 random trials. And that difference isn't extreme enough to say that that difference that we observed wasn't due to chance. But I wanted to delve deeper into what we could find just from random sampling in Python. So with Nora's help, put all this data into statistical analysis software, and this is what we found through there. So here, R is the correlation coefficient. So an R of +1 is a perfect one-to-one positive correlation. R of -1 is a perfect negative correlation. And P is a statistical significance measure. Generally, a P of 0.05 and under means that it is significant. So here we do find, and I highlighted in green, statistically significant findings or interesting ones. So here we find that there is a correlation between West Nile positivity, again, that's the percent, and the number of foggings and human cases is what we might expect. We also find a correlation between PDSI, the drought measure, and number of foggings, and temperature anomaly and number of foggings when we look at climate over the whole year and versus the season of that year. But I also wanted to zoom in on early year conditions, meaning January to March. As we know, the temperature and drought conditions during that period is really critical so that sea of mosquitoes can survive through that time. So we do see a stronger correlation between average temperatures during that period of time and the West Nile positivity of the season that followed that winter. And again, the correlation between drought, temperature, and the number of foggings as well. And then we did some more statistical tests. These are t-tests. And again, we do find a statistically significant difference between the number of foggings that we do during drought years and non-drought years. So in my conclusion, I wanted to talk about limitations, why we might have found what we found. So there was a lack of variability with the West Nile positivity rates. We were looking at a really small range, sometimes 0.5% to 3%. So it was harder to find the differences from year to year using just that percentage. And also our operations changed over the years. We used different traps types and different numbers of traps from year to year, and CalServe tracking might not have been accurate during those early years. We just don't know. In addition, the drought measure that I used, PDSI, didn't get so fine-tuned at the extreme levels. And human case data is just really tricky to work with. Someone could get sick in another county and bring it here. Someone gets sick here and bring it elsewhere. So it's harder to track. So if I had more time to work on the study, I would look at abundance, which is just here number of mosquitoes caught in relation to climate versus just looking at positivity rates and number of foggings. I might also look at abundance comparing different trap types. I might also look at different measures of precipitation in addition to the drought measure that I used. And there is evidence that extreme precipitation events after a dry spell, so say a rainstorm after a period of drought, could lead to a spike in mosquito breeding and vector transmission afterward, but I just didn't have time to look at that. But in summary, We weren't able to find a significant correlation between drought and West Nile positivity rates. There is a stronger but still inconclusive correlation between mild winter temperatures and West Nile positivity in the season that follows. But there was significant correlation between drought and foggings and average temperature and foggings. So there were more foggings during hotter and drier years. And yeah, thank you so much. And shout out again to Noor for all your help with the statistical analysis. And here is a snapshot of my bibliography. And again, thank you so much for having me, and I hope to stay in touch.